And last one, I'm gonna pick a white one. I'm gonna challenge myself, hopefully. I'm gonna pick this one. Hi everyone, my name is Zirui. I go by Colin. I'm currently a master's student at Princeton University where I work on multimodal large language models. Today I'm gonna answer some impossible questions proposed by other researchers. How to better handle non-uniform grid data at scale to build generative models? Wow, it's non-uniform grid data. What is grid data? I actually don't know. And what is non-uniform grid data? Okay, so I know generative models, like you can use it to generate images, you can generate text. I would assume that if this person mentions non-uniform grid data, I would say like it's more on the image side. I don't know what uniform grid data is actually. When can we go home and let machine learning models adjust all our hyperparameters for us? I think this is kind of like auto machine learning. I think we probably need to develop like better language models and vision language models to do that before we can have machine learning models to adjust our parameters, because we kind of need these like vision models to observe the loss curves, the trends before we decide whether we should try a lower learning rate or a higher learning rate based on different curves. You can have like different runs, and different runs give different loss curve patterns, and you need this kind of models to analyze the patterns in order to really adjust the hyperparameters automatically, like humans researchers do. So I think maybe my prediction will be like 2 years that machine learning models can adjust all the hyperparameters for us, and I think that would also be an interesting direction. What's a belief about model training that you've held on to for years but are starting to question? Oh, that's a good question. Okay, so one of the beliefs about model training is that I always think that larger models are better. Like usually you have larger models, and then with the same amount of data you get better performance. But recently I've also observed that it's less about the model size. It's more about the data quality. You can have a small model, but when you have better data quality, you can train a better model than if you have low quality data paired with larger model. So this is a belief that I initially had the thought that model size is more important than the data quality, but now I started to question, and I think that data quality is actually way more important than the model sizes. So this is my answer to this one. What's the best way to train a foundation model? Okay, nice. I worked on foundation model for sequential decision making. How can we gather and use massive amounts of data to train it? Let's assume that we have infinite data to train some kind of like sequential foundation model for sequential decision making. And because decision making can involve like a lot of like branches, when you make decisions, you branch out, and there are a lot of possibilities. I think it's important to consider the diversity of the data. So like if you have a massive amounts of data, I think it is actually important to curate the data first before you train the models. And it's important to curate data in a way that you prioritize the diversity of the data. So your foundation model, just knows more possibilities when it's doing the inference. So I think the best way to train a foundation model is to first have a good data curation pipeline that basically prioritize the diversity of this kind of decision-making data. That's my take on this one. What do you think will be superseded first, the transformer architecture or PyTorch? Wow. I think the transformer architecture will be superseded first. This is an easy one, it doesn't ask me to explain it, but I can talk about my rationale behind it. I think PyTorch is well established. Like I think over the years, it just getting more tractions over like TensorFlow, JAX, and I think all other deep learning frameworks. I think PyTorch is getting much more tractions, and we all love it. Like all our lab members, we use PyTorch a lot. And like every time someone else uses deep learning frameworks other than PyTorch, I just told them, switch to PyTorch. And I think a lot of people do the same thing because it just provides a good interface that everyone knows, everyone understands. So it's kind of like the operating system, the Mac OS, the Windows system that everyone knows. So I actually embrace PyTorch, and I think it's gonna last for a long time. Transformer architecture is just one of the architectures for machine learning. Who knows? What architecture can achieve even better performance, right? And we already see a lot of problems with transformers, especially in the long context setting, where if you have a very long video, transformers, because of the quadratic scaling nature of attention, it doesn't really do well. So I think some academia people, I would say in the next 3 years or so, they will come up with a better architecture that is better than transformers, and all the architectures will just we'll all experience that kind of architectural transition. But for PyTorch, I believe the best deep learning framework, and I think it's not going to be replaced in the next 5 or 10 years.